Alright, this is section 1.4. It deals with complex numbers. We're going to learn how to add and subtract complex numbers, multiply complex numbers, divide, perform operations with square roots of negative numbers. Alright, first of all, we're just going to talk a little bit about some basics. A complex number basically has two parts. It's a real number part and then also an imaginary part. So you can see, normally it comes in the form a plus bi, where the real number part comes first and the imaginary term comes second. So together, those are called complex numbers. Now, of course, if you just have an imaginary part, then you won't have the real part of the complex number. That's okay. But if you didn't have an imaginary part, then it would just be, obviously, a real number. First of all, we're going to talk a little bit about some basics. For starters, I is the square root of -1. So at this point in time, when we've been solving equations and we've had a solution where we're taking an even root of a negative number, we would put no real solution. Well, now we're opening up the door of having what we call imaginary solutions. And what we're going to do is we're going to look at some properties of imaginary numbers. So I is the square root of -1. I squared is basically this right here squared. So if you were to square that, you get -1. So important to know that. And then you can keep going in your nice little pattern. I to the third is basically going to be -I or negative square root of -1. I to the fourth is really going to be, if you multiply this by I, you get -I squared. But -I squared, as you can well know, if you multiply I squared, which is -1 times negative, you'll get a +1. Now, a lot of times, especially on your ACT and stuff like that, you'll see a pattern that repeats. So this is the same thing, because it goes, this is I to the first, I to the second, I to the fourth, I to the first, second, third, fourth. I may have skipped 3 there. And then this is I to the fifth. This is equivalent to I to the sixth, I to the seventh, I to the eighth, I to the ninth, I to the 10th. And anytime you have a pattern like that, it could be like a stoplight, where the stoplight will go, obviously green, yellow, red, green, yellow, red. If you want to figure out, hey, what color is it going to be on after, if it starts on red, 300 times from there, or 555 times. So we'll look at a little example. If I want to figure out what I to the 127th power is equivalent to, what you have to do in a pattern like this is you're going to take how many things are in the pattern. So there's 1, 2, 3, 4. And we're going to take that exponent and divide it by 4. Well, 4 we're going to 12 3 times. 12, subtract, 0, bring down our 7 once. So 4, 3. All right, and the big thing that we're trying to figure out is not so much how many times 4 goes into the number, but what our remainder is. So as you can see, we have a remainder of 3. Anytime you have a remainder of 3, it's going to be the same thing as I to the third. So this is really going to be equivalent to the I to the third, or you could say it is negative square root of -1. So you can see that anytime you see a pattern like that where the pattern repeats and you need to figure out one later on, just take how many unique things are in the pattern and divide it by the number in the sequence that you're looking for. And what you need to know is in this right here, this would have a remainder of 1. This would have a remainder of 2. This would have a remainder of 3. And you would think this would have a remainder of 4, but that's not true because then 4 would go into it one more time. So it actually has a remainder of 0. So just some little basics on complex numbers. Hope that helped.